Okay, well, just to do a problem with the binomial random variable to get warmed up, we have this problem that a basketball player is fouled shooting a three-point shot at the final buzzer with their team down 2 points. And they go to the foul line, and the whole game is sort of at their fingertips. They shoot three shots, they're down 2 points. So if we model this with a random variable x, which is the number of shots made, we could consider it a binomial 3p random variable. It's a model, of course. This assumes independence, and that's maybe probably not a very good assumption. Also, if the player misses the first two shots, they're probably not going to even try to make the third shot, but because they won't be able to tie it or win after that. But let's assume that, let's model it by assuming it's binomial. They have three trials, and the probability of making a shot on each trial is p. Then the probability they win is on the foul shots is the probability x equals 3. So this, let's write on the free throws. Probability they go into OT on the free throws is if they make exactly 2 of the 3 shots. And probability they lose is if they don't make any or they make 1. And the additional consideration is that if they go to OT, then the probability they win is a half because they play another 5 minutes and say they have a half chance to win then. So we want to know the probability they win overall under these two different situations. The player is a pretty good free throw shooter, 75%, but not great, or a very excellent free throw shooter, 90% free throw shooter, makes 9 out of 10. And let's see what the difference is. So, well, we can compute all of these. We know all of these. So let's just do it. So probability probability lose will be 1 minus probability win. So probability win is just equal to probability x equals 3 plus probability x equals 2 times probability they win given x equals 2. So probability win given x equals 2. This is win given x equals 3, but that's 1. So it's 1 times probability x equals 2. Okay, so this is equal to just probability x equals 3, which makes all three. So this is p cubed. Plus probability x equals 2, win given x equals 2, so this is a half. And the probability x equals 2 is 3 choose 2, so it's 3 times p squared times 1 minus p. Okay, let's continue to compute this out a little bit. So we get equals p cubed, and then I have 3 halves here, so I have, what do I have? 3 halves minus, so I get 3 halves p squared minus, I have p cubed minus 3 halves, so that's minus 1 half p cubed, or p squared times p squared over 2 times 3 minus p. Does that look right? 3 minus p, yeah. So if p equals 3/4, this leads to probability of a win equals to, what comes out here, I have 3/4 squared, I get 9 over 32. And now I have 3 minus 3/4, so that's 9/4. 81 over 128. And if p is 9/10, we get P win equals, let's see, it would be 81 over 200. And here I would have 21 tenths, which is equal to, let's see if I did this here. Yep. 1701 over 2000. All right, so this is approximately 0.85 to get us, so we get a better feel for this. And this looks like approximately 0.7 or what the hell? Yeah, even less. So 0.62, something like that. Okay, so bigger, much better chance with a good foul shooter there. All right, well, that is the binomial. We can compute the binomial iteratively. So we want to do this more, not because we will be doing a lot of computing by hand on this, but because of just insight into what it is. So what the probabilities are. So it should say computing binomial probabilities. Iteratively. Okay, suppose to start, let's just do an example. Suppose x is binomial, say 10p, and let's compute a bunch. So probability x equals 0 is 1 minus p to the 10th. Okay, and let's call this, just for convenience, p sub 0, little p sub 0. Probability x equals 1 is p 1 minus p to the 9th. I should have wrote the, I'll just write the choose thing here. So it's going to be 10 choose 1. All right, so I want to write this in terms of little p0. So I can see how to do that. It's p over 1 minus p. And here I have 10 choose 1. So 10, let's just write 10. And here I have p0. Okay. So I write this as 10 p over 1 minus p times p0. Okay, we have to keep going to see the pattern. Probability x equals 2 is equal to p squared, 1 minus p to the 8th. I see that's multiplying, again, what's up here by p times 1 minus p, at least on this part. Now I have to correct this. I have 10 choose 2. Well, let's see, that's 10 times 9 over 2 times 1. So let's call this 10 over 1 up here, and then call this p 1 minus p. We'll call this whole thing p1. So if I take another p 1 minus p, I come down to this now. And if I multiply the top by 9 and the bottom by 2 of p1, I think I'm there, right? Because this will be 10 times 9 over 2 times 1, p squared over 1 minus p squared times p0. I can see that's right. And I can continue like this, right? We can continue, keep going until we get all of them in this form. So p3, what do you think px equals 3 is? I'm just going to dispense with this now and just say, in terms of p2, it's going to be p over 1 minus p. Now here I have 8 over 3, the new ones, p2. Okay, and it continues like this, right? Continues like this. So it will even, this fraction here will become less than 1 as I get close to 10. It just continues. So let's see. So if we go in general, probability x equals k, this will be p over 1 minus p. Up here, I have, down here, I have k. Up here, I have n minus k plus 1, I think. And here I have p k minus 1. Okay. Yes, that's the result there. So if you knew one, say, you can do the rest. So let's maybe just do some of these. So for example, maybe pick something a little easier. Say x is binomial, say 5/3. Then probability, you have to do 1. X equals 0 is equal to all fails, right? All fails, 5 of them. So I have 2/3, 1 minus p to the 5th power, right? So we have 2/3 to the 5th, 32 over 243. So px equals 1 is just equal to p over 1 minus p. So you can do that ahead of time. P over 1 minus p is 1/3 over 2/3 equals 1/2. So I get this factor of 1/2, so I have 1/2. And now I come down to 5 minus 1 plus 1, so that's 5 over 1. And here I have the previous one, right? So P0. So this is equal to 5/2 of whatever was up here. So I get 80 over 243. Let's see where we are. Okay, we're running out of time, but we can do a little more. So let's see, px equals 2. I get 1/2 again. And now I have, I come down one more. I get 4 over 2. P1. So that's just the same. So I get 80 over 243. That's equal to P2. X equals 3. Another 1/2. I have a 3 over 3. So P2. So that's just 1/2 of what was here. I have 40 over 243. Continuing, I have Px equal 4, 1/2. And now I have 2/4. P3, so I get 1/4 of this, 10 over 43. And lastly, you could do it, but let's see if it works. Px equals 5 is 1/2, and I'm down to 1 1/5, P4. So I get 1/10, so I get 1 over 243, which is right, this P5. Okay, that looks good. I'll see you on the next one.